So the way your textbook does this, reserves, I'm going to try to stay in line with their notation, equals required reserves plus excess reserves, not EB. That was not a Freudian slip. I don't think you got that. It's on the tape. You can read it. All right. So what were required reserves?
Federal bank.
To have. Not so much to count, kind of. I mean, but that's not, just in general terms, required reserves. Who sets them? The Fed. So it's rules or laws. If you want to run a bank in the United States, you have to be monitored by the Fed in some capacity. And so they're going to require that a fraction of your deposits are held back, right? Which is kind of a safety thing. And so another way to think about that is that the required reserves is the required reserve ratio times the amount of deposits that you have plus excess reserves. Where little r is the required reserve ratio, that's the policy tool that we talked about that the Fed sets, the amount of reserves that they hold back. So we've got R equals reserves, just to get some of these terms. Little r is the required reserve ratio, that's the one set by the Fed. D equals total deposits by people who put money at your bank, right? Total deposits is D. RR equals required reserves. I'll write it out. The formula's already up there. And then finally, ER is excess reserves. So that's the way we kind of set up thinking, how much money can I loan out? I can loan out anything that's above my requirement is potentially fair game for that. All right, so then we talked about the monetary base, MB, the monetary base. And who remembers that from last time? Does anybody take notes? That's the one reason I like to do whiteboard rather than PowerPoint, because I think sometimes you tend not to. C plus R, good, yeah, C plus R, good. So the monetary base is equal to C plus R. What's C? Currency. And what type of currency specifically? Currency in circulation outside of a bank, right? So it's cash, actual currency that's outside of the bank, plus R, which is the total amount of reserves that we have out there. All right, so now we can start playing some little algebraic games here. So we got currency plus R, which is really RD plus excess reserves, substituting in this equation into there. And then we're going to add another little flair onto here. How much currency is out in circulation can be thought of as a fraction of deposits. So little c, which I'll define in a moment, little c is the fraction of deposits that's being chosen to be held as currency out in circulation, plus RD, plus ED. Where this now is substituting for excess reserves, saying that it's really a choice variable by banks on how much excess reserves they may choose to hold. So if a bank loans out all of their excess reserves, what is E equal to? 0? Right? 0 times the amount of deposits, they chose a variable 0. So we're changing it into a parameter that now gauges the fraction of deposits. Now, what you see here is kind of nice, because what can we do with our little algebra deal here? We can suck out, we can move them around, but what can we do with the d? We can take it out. We can divide by d to one side, but also just factoring out the common thing, right? So what this ends up leaving us with is that we can think about the monetary base as the sum of these factors times the amount of deposits in the system. Right? So this is total deposits in the banking system, and that is a combination. What makes up the monetary base, I'll just bring this down here, but it's the same thing, we've just been working this problem down here, is the currency ratio, the required reserve ratio, and the amount of excess reserves that the bank wants to hold, right? It's cash. And so these represent the currency drain. Where we're going with this ultimately is to come back to the multiplying process, the multiplier. And so, let me see if I should sneak that in here or not. Let's not do that right now. I'm going to come back to that in a second. All right, question tag? All right, everybody cool with this?
On the jump down from C plus RD equals QR to the CD plus RD plus CD, what do we know?
Here?
Yeah, how do you get to there again?
We just expressed the total currency in circulation as a fraction of the amount of deposits. So how much of my wealth do I want to hold as currency? The fraction of your deposits that you're choosing to hold as currency. Chisholm? Okay. Let me write out some of the factors here on what they are. We're going to go through an example later too, but all right. So let's put a little here note. We're kind of adding on. Little c equals the fraction of deposits. Yeah, it's the currency ratio, yes. So little c is the fraction of deposits that are being held as currency. So in the big system, that it's kind of hard to get big. This is big C, little c. Don't forget that. Big C, little c. The amount of currency in circulation can be shown to be a fraction of the deposits. That helps out. All right, and then R we already defined. Little r is the required reserve ratio. We did not define E yet. E is the fraction of deposits that the bank chooses to hold as excess reserves. All right, now we're going to do the trick that maybe Jacob was talking about, to express the deposits as a fraction of the monetary base. So rewriting, we can call this equation star. Rewriting equation star, deposits are equal to 1 over C plus E plus, oops, out of order, C plus R plus E times the monetary base. Right? All I did was flip this sucker over to the other side. All right, so let's call this equation 1. deposits in the banking system can be shown to be a fraction, or it turns out to be a multiple actually, of the monetary base. All right, so at this point, let me do a little recall. Recall the simple deposit multiplier. For some of you not knowing exactly what you had for macro, you probably did this, but we did it in our macro class here. So recall the simple deposit multiplier. What it is? Put pressure on Joe since he's the econ tutor. Everybody remember that? We did it in that exercise. Let me put this thing down. This is where we left off last time. What was the multiplier, the simple deposit multiplier here in this example? 10. The number was 10, right? So deposits grew to $1 billion after $100 million, right? So this was the process that we were describing, but I didn't show you the formula last time. That's where we left off. But we did have that back in Principles of Macro class. Yeah. The reciprocal of the reserve ratio. Yes, yes. So 1 over R ends up being it. So in this example, 10% is the required reserve ratio. 1 over 0.1 or 1 over 1/10, right? 1 over 1/10, because this is 0.1. Flip that over, equals 10. So the multiplier, the simple deposit multiplier, is just 1 over the required reserve ratio. What that assumes, that again we went over in a long time ago that I really don't expect you to remember, but now you need to know it for this chapter, is that that doesn't work out to be 1,000 for what reasons? What reasons would cause us not to have deposits grow in terms of it enters First National Bank loans it out. Loans out 90, holds back 10, loans out 81, right? So the increase in loans. What causes that not to get the whole 10? If they don't deposit their money. So if people don't deposit their money in the bank, that was our currency drain, right? And then what's the other reason that we would not expect it to be 10 in the world? Excess reserves. Banks choosing not to loan out the maximum that they could. Right? So that is what we've got here, starting to be incorporated into the formula. The simple deposit multiplier was 1 over the required reserve ratio. Actually, it's the change in excess reserves, not the monetary base. So I'm building up to something, but I wanted to kind of show you that that sucker right there is kind of connected to this multiplier business. So the simple deposit multiplier equals 1 over R. And you might have a homework problem or a test problem that asks you that. So the simple deposit multiplier is 1 over R, and the change in the money supply is equal to 1 over R times the change in excess reserves. That's the formula that we follow for the simple deposit multiplier. In the example we just did, it was 10. 1 over 0.1 equals 10. 10 times 100 gave us 1,000. Okay, everybody with me on that? Make sure you're with me on that. Ask a question. Did I hear the delta question? Money supply. So this is actually, now we're going to be converting it to money, not MB, monetary base. But that's what we're going to bridge the gap on. So the idea here was, if the Federal Reserve does a monetary policy action, and we go back to the Keynes liquidity preference framework where we got money supply, money demand, which was just on this last test that some of you, I think, need to clean up on, right? So when the Fed changes the required reserve ratio to 20% instead of 10%, then that shifts the money supply to the left, tightening up money, raising, I'm sorry, I got money here, interest rates, raising interest rates. Okay, so that's kind of the dynamic that we're trying to look at with the Fed's changes in open market sale or open market operation or an open market purchase. Okay, any other questions here? All right, now let's bridge this to M. So let's just let, your textbook does this, so I'm just kind of following their rule. Let M be equal to M1, right? And I'm just doing that because the textbook does it this way, and I want to, so you guys have this consistent. What was M1 equal to? That was on your test. M1. Currency and checking account deposits, right? So currency plus checking account deposits. So we've got deposits plus currency. Currency in circulation plus checking account deposits. We're just going to call them deposits. So we're kind of simplifying our economy a little bit with deposits being all checking deposits. All right, now, I think I'm going to erase this here. All right, so now, using what we were doing there before, how can we express currency as a fraction of deposits? So take this and express that equation, the M1 equation, the quantity of money, remember, is what we're getting at. Express the quantity of money as a fraction of deposits. We've got the D here already. What can we do here? Let's see. We can do what? Small c, big D, right? Yeah. So the same convention we did here. So we can express our currency as a fraction of deposits, which then we can suck out the D. And now we've got deposits equal to 1 over 1 plus the currency drain, or the currency fraction, times M. Call this equation 2. Everybody cool with what we did here? Just kind of follow the same logic down. Set equation 1 equal to equation 2. And solve for M. I'll let you guys do this one. I don't want to nurse you through it. Set equation 1 equal to equation 2. I want to see that on all your papers. If you're doing it on a computer, I can let Eric do it if you want. You've got deposits, right? You got a D here and a D here. So those two equal to each other and solve for n, right? Okay, that's good. So what you want to do now, solve for M. Yeah, but clean that up so that MD is on the outside. Just like kind of like what you have here. Make it so that that one thing is all the same. Okay. So you got the equation 2, right? So just go ahead. They're both equal to D. So there's that's equation 1, right? Make sure you identify that one good. So then that is D equals this, and then the last one we just did is D equals that. And then so they're both equal to D, so set them equal to each other. Amy, what's up with you? I'd like you to solve the equation. So set 1 equal to 2. You got some milk picture for this later, yellow? Borrow one. All right, did you get it? All right, so get this all by itself. You're fine, you're correct, but kind of collapse that down. The MB is just on the outside.
Like MB is just.
Yeah, kind of like what you got written here. Okay, I don't think you messed up. So get that thing over here. You need to flip that and multiply it times that. That's all we're looking to do. Yep. I would throw the M on the other side because we're solving for M. But you're right.
Yeah.
That's true. You're doing too much. So if you're solving this, you want to get this over to the other side. The reciprocal, and then just leave it. So M's all by itself, and it's equal to that.
You don't have like one sign.
Yeah. So right now, combine that together for one more step.
Right.
Okay. Well, no, you're actually close to the index. So now, if you put this expression to solve for M, put this expression over here.
Oh.
And just taking the reciprocal of that, telling into the side. Yeah. Yep. You can't simplify that C. Yeah. There's no reductions that'll work for that C. Okay, so you need to set them equal. With this. Where's your equation 1 and 2? I guess it'd be easier. Yep, that looks great. Joe, how's yours going? You're closer than you think. You're closer than you think. So your D was equal to both these. So now you're kind of looking at that. So all you're trying to do is solve for M, so you can get this sucker over to the other side. So you multiply by the reciprocal, 1 over 1 plus C over 1. And then put that over here. That's what you do. See that? Where's yours, Dallas? Well, lay it out for me. That's what I want to see. Everybody lay this out. All I'm asking you is to set this equals this, because they're both equal to D. Right? And it's really, once you guys see it, but I don't want to assume that you know how to, that you get it, because sometimes we're not all on the same page. You just don't want to make the first step here. All you got to do is just work it. All right, so at the end of the day, it looked like most of you who started it to work it got 1 over 1 plus C times M equals 1 over C plus R plus E times the monetary base. Just get this sucker over here, right? And now we've got the quantity of money as a fraction of 1 plus C over C plus R plus E times the monetary base. This is the equation that the Federal Reserve really uses. When they do monetary policy, this is the one. This is called the money multiplier. So instead of the deposit multiplier, we call it the money multiplier because it's shown as a fraction of the monetary base. So this thing is the money multiplier. This ugly looking thing is the money multiplier. Okay, so what was the monetary base? Why do we care about the monetary base?
Money borrowed.
The amount borrowed, it's the base that's supporting the system. So who knows what the monetary base is in terms of its trackability? It supports how much money is out, right? So the Fed has those, if we go back to the Fed's balance sheet, let's check it out here. This is the first thing we started on. What is the monetary base?
Liabilities.
Liabilities of the Fed. So in terms of their balance sheet, this is what they track. So the liabilities of the Fed is the monetary base. Why they track that. And so when they change the monetary base, they estimate the value of the money multiplier to see what its impact is going to be on the money supply, quantity of money out there. Okay, questions on that? I know it's a little confusing. You might have to work through, so hopefully some of the stuff in your reading will make sense now as you work through the book. Or I know some of you have already done the reading.
Yeah, you said it supports how much money is out. You're not talking about circulation.
The deposits and everything, yes. So the money supply is what? M1. We already did it. I'm just trying to review. The money supply, currency in circulation plus checking account deposits. Now, if we get to the big picture, M2 adds in savings account deposits, right? So it's basically all the deposits of the banking system. Who has access to the money supply? Banks or people who want to do transactions? People. So that's the connection here, is that the Fed has liabilities, part of which they control, right? Currency and circulation, they control. I mean, they allow the currency to go out. And then the amount of reserves in the system, which they set by the little r and all these other factors. And so what we're doing is we're trying to bridge the gap between the monetary base and how it supports the big money supply, the supply of the supply of all deposits and currency in circulation. So it's really this factor that ends up giving us the loan process, right? Because the fractional banking system that we have, the fact that the bank can lend out 90% of your money, right, of using other people's money, that's what creates more money. And so this is establishing the link then between the reserve ratio and the amount of reserves and the deposits in the system. Okay, any other questions? I'm going to write a few more things out. Okay, this will be in more language rather than equations here. So, all right, so think of reserves as a potential source of money, a potential source of money creation, from two sources. One, required reserves. The Fed can change little r, the required reserve ratio. So the Fed can change the required reserve ratio. Two, excess reserves. Banks can reduce excess reserves and loan out more money. So if the amount of reserves in the systems equals the required reserves, the amount of reserves equals required reserves if excess reserves equal 0, which was one of our equations before. The bank's not holding on to any money. And what came out with our little equations is that little e equals 0. Little e equals 0. All right, and the monetary base is the liabilities of the Fed. The monetary base is the liabilities of the Fed. All right, where this gets a little bit murky is trying to think through an individual bank's behavior, depositors' behavior, and then the Federal Reserve. We got to keep all three of those agents in line. So anybody have any questions? All right, let's see how well you did. A little example here. Suppose that the required reserve ratio equals 0.1. Little r equals 0.1. Currency, C, in circulation is 400 million. Big C. Checkable deposits, big D, is 800 million. Excess reserves equals 0.8 billion. 0.8 billion. Money supply, M, which equals currency plus deposits, equals 1.2 billion. So 1,200 billion. We've been throwing the B's. 1,200 billion. 1.2 trillion. All right, so what is little c? 0.5, right? So little c is this fraction. We know this one and we know this one. So we've got big C over D, 400 over 800 billion equals 0.5. So our little currency ratio is 0.5. What about little e? 0.01. So we've got the 0.8 billion over the 800. equals 0.01. And so finally, what is the money multiplier? Little m, which I actually didn't define over here. That's this. The money multiplier is little m. Now go back to your formula and calculate that out. What is the money multiplier? And we're really just plugging and chugging, right? .5 over 0.601. What'd you get? 2 point what? 2.49? 2.5, rounding up. So the money multiplier is 2.5 times the monetary base. So to calculate changes then, we end up using the money multiplier. What would have been the deposit multiplier using these numbers? What was the simple deposit multiplier? 1 over R, which would be, what's the magnitude of it? 10. The multiplier would be 10. But when we factor in currency drain and the excess reserve, it ends up dropping to 2.5. So there's less of a multiplying effect, which is the answer we were expecting to get, right? So it's a fourth of the deposit multiplier. All right. We will call it a day there. All right, those of you who came in late, why don't you come up front with your sheets? Yeah. What's that? It would be, yes. So now if you take the next step with this, if you were asked to count that's right. So just this chunk. Yeah, that's why I was highlighting this. This expression is the money multiplier. This is big M, the money supply. Yes. Got it. We got it.